Oh iya.
Oke.
Indonesia. Oke.
Oke.
Can you guys see the screen?
Yes.
Yes.
Okay. So, good evening, everyone. And now I will describe the PPT about the question in chapter 1. Our chapter 1 is basic concept in medical statistic. So the first question of section 1 is, the research object of medical statistic is. So first of all, we have to know what is medical statistic and what is the relationship with the statistic. So medical statistics deals with application of statistic to medicine and the health science, including epidemiology, public health, forensic medicine, and clinical research. And the use of statistic allows clinical research to draw reasonable and accurate inference from collected information, as well as the data, remotely, and to make sound decisions in the presence of uncertainty. And mastery of statistical concept can prevent numerous errors and biases in medical research. So, the main purpose of using statistic is to when the collected data in terms of experimental designs and statistical surveys. And we know that in medicine, as well as other things, there are so many kinds of data for us to conclude and for us to research. And that's why we need to use statistic in medical. So in this question, I choose B.
Wait a moment.
Yes, Marsha.
For section 1, you describe the definition of the statistics is correct, but pay attention to the questions. Yes, there are many or very more types or various types of data in our medical statistics. You just learned the descriptive statistic. It includes quantitative data and qualitative data, right? But the purpose of our medical statistics is not the data themselves. We wanted to use the types of data, and then we have to analyze the data and then make a conclusion. We use the conclusion to do the test and use it in the clinical medicine. So the purpose is E, the last one, the mutated medical events. The final purpose or object is the events. And then we count it, we have the data and mutate it and have a conclusion. Okay?
Okay, Larsha.
Okay.
Thank you. And then we move on to the second question.
Yeah.
So the second question of section 1 is use samples to infer the population. And a representative sample is, so a representative sample is used in statistical analysis and is a subset of a population that reflects the characteristic of the entire population. A representative sample is a group or set chosen from a larger statistical population according to specify the characteristic. In a nutshell, a representative sample is when your sample's demographics should roughly match the population. So here I choose D, a subset of individuals extracted by a matching method.
Wait a moment. Here just means we use samples to infer the population. So the very important thing is we have to choose a representative sample. Yes. So first one, the most accessible part of the population is individual. So if we choose the most accessible, just like we have a group of data from 1 to 10. So if the most accessible is 1 from 5, then this group, the average mean of this group is far away from the mean of the population. So it is not representative. B, you pick any individuals in the population. It's also not a random sample, yes? C, select the representative part of the population, individual. I want to know why you don't choose C. The reason is what?
I think that what
is the reason?
So first of all, I would like to choose C, but when I search it again, I feel confused because this one, a matching method, I think it's related to at this point the characteristic.
Yeah,
I think
C is wrong. Yeah, C is wrong.
Yes.
C is wrong. Because we don't know which part of the population is representative. We have to choose data according to the random sample principle. This is the standardized. Yes, this is the standard. So for this question, why we don't choose D? Here means a subset of individuals extracted by a matching method. If we use the matching method, especially the data is similar to the population, but it don't follow a random sampling principle. So the result of the subset of the individuals. Here the wrong word is the subset. If we choose a subset of these individuals, the result may don't have any meaning for the population. In any conditions, we choose a sample, or we select some data or individuals from the population. We have to according to the random principle. Random principle is the basic principle to select sample. So for question 2, we have to choose E, the last one. Okay? Okay, thank you. Move on.
Okay, now we move on to the third question. So the question is, which of the following observations are rank data? So first of all, we have to know what is a rank data is. So ranking in statistic ranking is the data transformation in which numeral or ordinal values are replaced by the rank when the data are sorted. For example, there are numeral data 3.4 and 5.1 and then 2.6 and the last one is 7.3 are observed. The rank of this data item would be 2, 3, 1, and 4 respectively. The 3.4 is the second one, and then the 7.3, 2.6 is the first one, and then 5.1 is the third one, and then the last one is 7.3. And we know the characteristic of rank data is the observation units are sometimes the same or there are qualitative difference. And then there is only order between the grades and no numbers of values. So that's why I choose degree of condition.
Okay, can you tell me how about the A? What's the type? Is a qualitative or quantitative data?
I think it's quantitative data loh siya.
Quantitative, yes?
Yes,
Yes, very good. Because it has a unit. We
Yes.
can measure it. Yeah, very good. So second one, the parse number.
the second one, I think it's also quantitative data loh siya.
Yeah, very good. Yes, especially beside the D, other one. No. And the A, B, C are quantitative data because they have a unit and we can measure it by some stool. Yes.
Yes loh siya.
E is a quantitative data. It's just a type. Yes.
Yes.
Okay, very good. Next.
So we move on to the fourth one. So the fourth one is random errors refers to. So we have to know what is random error is. So random errors is divided to two types. First one is sampling errors, and then the second one is random measurement errors. So random errors is due to some non-human accidental factors. The result is either larger or small, which is uncertain and unpredictable. And its characteristic is decrease with the number of measurements. And for what I can search it, that all the data contains random error because no measurement system is perfect. The magnitude of the random errors depends partly on the scale at which something is measured, or there's errors in the molecular levels measurement will be on the order of nanometers, whereas errors in human height measurements may be on the order of 1 or 2 centimeters. And it's partly on the quality of the tools used. And then my answer for this question is E, error caused by accidentally factor.
Yes,
Because it refers to this sentence.
Yes. Very good. Your elaboration is so perfect.
Okay, Lasha, thank you. And now we move on to the last question in section 1. Number 5 question is the inevitable error in collecting data is? So I choose E, random errors, because random errors are intermediate errors caused by uncontrollable variables which cannot be defined or eliminated. Just like what we explained in the previous question about random errors. So that's why I choosing E.
With A?
Yes, A.
Yes.
I mean, I'm sorry. Yes.
Yes. Okay, your answer is correct. Okay.
Yes.
Very good.
Thank you, Marsha. So we move on to section 2. So the first question of section 2 is, what are the 3 common types of errors and what measure and methods should be taken to control it? So first of all is systematic errors. Systematic errors is due to the inaccuracy of instruments and non-standard standards in data collection and measurement. The observed result tend to be larger or smaller, we just call it systematic error. And the systematic error's characteristic is it is accumulative. And then the sampling errors. So the difference between the sample index and the overall index due to the sampling reasons, and the sampling error characteristic is sampling errors is inevitable.
Yes.
And the last error is random measurement error. So under the premise of eliminating the systematic errors, the results are not exactly the same for the same sample for many times due to non-human accidental factors. The results are sometimes too large and sometimes too small with no tendency. The features, no bias. Multiple measurement calculation of range can reduce or even eliminate random measurement errors. And what measure and method should be taken to control? So, the difference between the sample index and the overall index due to sampling reasons and the characteristic sampling error is inevitable. Statistically, the sampling error can be calculated and controlled within a certain range. And the method for reduce this sampling error is first, increase the sample size n, and improve the sampling method to increase the representativeness of samples, and sampling errors of different sampling methods when the sample size n is equal. Cluster sampling, and then simple random samplings, and then systematic samplings, and stratified sampling. And then select the research indicator with less variation. That's for sampling errors. And then systematic errors can be located and minimized with careful analysis and design of the test conditions and procedures by comparing your results to other results obtained independently using the different equipment or techniques, or by trying out an experimental procedure on a known reference value and adjusting the procedure until the desired result is obtained, or we call it calibration. We could reduce random measurement errors by taking repeated measurements, using a large sample, and controlling extraneous variables.
Yes, very good.
Okay, and now we next to the second question. The second question in section 2 is, what are the 3 characteristics required of each sample in sampling? So the first one is reliability. The experimental result should be repeatable, that is, the overall conclusion inferred from the results obtained from the samples of the scientific research subject should have greater credibility. And due to the difference between individuals, only a certain number of individuals can be observed to reflect their objective regularity. The more the content of each sample, the greater the reliability will be. But the increase in the number of cases, the human and material research will be difficult. So enough should prevail. And then the second is regularity. The more the content of each sample, the greater the reliability will be. But the increase in the number of cases, the human and material results will be difficult, so enough should be prevail. Representativeness is requires that each individual in the sample must conform to the general provisions, equal chance, to ensure that every individual in the population has the same probability of being selected sample.
Okay. Wait a moment. Wait a moment. The first one, reliability, is correct, but please pay attention to the second. Regularity is also very important, but I think the randomness is more important than regularity. I sent the elaboration to our group. Okay, please pay attention to. Please change this one. Randomness. So the most important principle of sample is reliability, randomness, and representativeness. Okay.
Okay, Larsha.
Okay. Thank you.
Thank you, Larsha. So we move on to the last question. So the third question is, what is the comparability between two samples? So the comparison of two sets of observation is a very common problem in the biomedical field. Two samples are said to be paired when each data point of the first sample is matched with a unique data point of the second sample. So when two ever independent samples are taken from normal population for the purpose of comparing their means.
So you means matching?
Yes, Lash, I'm sorry, I can hear you clearly.
So here you use the comparison of two set observations to paired. Yes, paired always means matching. Yes.
Yes, Lasha.
So we can control some affect some influence factors. Yes, very good.
Lasha.
Okay, thank you for your perfect elaboration. I think you do a hard work on chapter 1, and your elaboration is also very perfect. Your PowerPoint is lively, so good. So I will give you the whole scores of this part. Thank you so much.
Thank you so much, Lasha.
Okay,
Thank
next.
you for your
Okay.
all, guys. Thank you, Lasha.
Okay, next.
Sorry, Rosa, I cannot share screen.
I'm sorry. Wait a moment.
Okay.
So are you ready?
Indonesia 老师有问题。
Okay.
Can you see the screen, guys?
Yes.
Yes.
Yes. Okay.
Yes, I can.
I will presentation descriptive statistic of chapter 2, session 1. Type of data. Can you hear me?
Yes. Yes, move on.
What is nominal data or data that one can map? They are not measured but simply counted. They often consist of loaded feature or type observation, for example, death or alive, male or female, truth or not truth, pregnant or not pregnant. However, they often can have more than two categories. For example, blood group O, A, B, and AB, country of origin, racial group, or social class. The method of presentation of nominal data are limited in scope. Continuous data in medical study and how to find diastolic nominal data. Okay. Sorry guys. And I have three examples of season 1. What is continuous data in medical study and how to find historic nominal data? Often the case in medicine, the continuous data are determined to make nominal data to diastolic blood pressure, which continuous is converted in hypertension criteria that 90 millimeter mercury and normal tension 90 millimeter mercury is clearly into a loss of information, but often makes the data easier to summarize. And question number 2.
Sorry.
Yes, also.
For question 1, what's your answer?
My answer is, what is continuous data in medical study and how to find the historic nominal data? And I answer is, often the case in medicine, the continuous data are dichotomized to make nominal data.
I'm sorry.
How was also?
Wait a moment. I'm sorry, wait a moment.
Yes.
I will see the this question. I think this question is not in the chapter 2. Yes. How about other students?
Chapter 2, season 1 also.
So you just elaborate the type of data, or the first one, the first part. This is the question 1, which is the continuous data in medical study. This is the question 1.
I think no.
I see. So Pen Wei you just elaborate the type of data, or you start elaborate the homework.
How about number second also? Can you see?
Homework.
Number 2.
Okay, please turn to next slide.
Yes, also. How about this?
I'm a little confused. I think this is not the questions in chapter 2. Yes. So, how about your question? From where? Can William?
Yes, Rosa, sorry, Rosa.
I want to know because I'm a little confused. I think I didn't send this question. Yes.
Yes, Rosa, I'm wrong.
Okay, doesn't matter. You can move on. Move on. Yes. I want you master the points of descriptive statistics. It doesn't matter. You can move on. Okay.
Yes, Rosa.
Okay.
So, next, Rosa.
Yes. Yes. Question 2.
Question 2. A group of data diastolic blood pressure is shown as follows. What is the median value? There are 1, 2, 3, 4, 5, 6, 7. In answer is 10 divided to 16 divided to equal x value of x and 94 plus 96 divided to. So 190 divided to equal 95 millimeter mercury.
Yes. Very good.
Next season 3 also.
Yes.
Next season, sorry.
Yes. Very good.
Oh, yes. And number 3 presented some microbial sample number from 6 different areas. 100, 1000, 10,000, 100,000, 100, and 1 million. What is geometric mean? And answer is xg express goal equal LG 100 plus 1000 plus 1000 plus 100,000 plus 1 million plus 1 million divided 10. So 2 plus 2 plus 3 plus 4 plus 5 plus 6 divided 6. And 22 divided 6 and 3.66 equal 457.8x1x96.
Okay. Here the geomic mean always used in the basic medicine, especially when we do some some pharmacy experiments in the animal. So we will use this mean. Yes. You do a good job. I think this part is a little difficult. Okay.
Yes, also I make a presentation of another books. So,
Okay. Thank you so much. I think we learned
yes,
more.
also.
Yes,
I'm
we
sorry,
learned
also.
more. It doesn't matter. I think other students also learned more
Yes.
from your PowerPoint. Okay, that's okay. Okay, thank you so much. Okay, next students. Lin Yongfu.
Thank you, guys. Thank you, also.
Okay.
Good evening, everyone. Can you hear my voice?
Yes.
Yes. Yes.
So I am proudly present the material for our study under the title Calculation and Analysis. Firstly, I will explain our materials. So I will start from the mean. Mean is the average or the most common value in the collection of number. The statistics, it is a measure of central tendency of a probability distribution along median and mode. It is also referred to as an expected value. So how to calculate mean? Mean is the total of the sum of all values in a collection of numbers divided by the numbers of numbers in a collection. It is calculated in the following way. So we can see here is the formula. X is population mean, sum X is sum of its value in the population, and is number of values in the population. Next, steps for
Lin Yongfu, wait a moment. Turn to
yes,
turn to the previous slide.
okay.
I want to add something. Please pay attention to the x. If we have a 9 on the x, we read it as x bar.
Yes.
Okay, thank you. Next.
Step for the calculating the mean. We have two steps. First, add up all the values in the data set, and then divide this number by the number of values. Example. We will walk through these steps with a sample data set. Okay, so I have the data set here. Let's say you want to find the average amount people spend on a restaurant meal in your neighborhood. Okay, you ask a sample of 8 neighbors, 1, 2, 3, 4, 5, 6, 7, and 8. How much they spent the last time they went out for dinner, and find the median cost. Okay, the step 1, find the sum of the values by adding them all up. So we have to adding all the data set, and then we found the answer is sum X is 400. And then go to step 2, divide the sum by the number of values. The sum of number, we have to divide by the number of values, and then 400 divided by 8 equal 50. So the mean tell us that in our sample, participants spend an average of $50 on their restaurant bill. So that's the example of the mean. Let's continue to the median. The median is the value that exactly in the middle of the data set when it is ordered. Its measure of central tendency that separates the lowest 50% from the highest 50% of values. Sorry. The steps for finding the median differ depending on whether you have an odd or an even number. So you have an odd or an even number of data points. If there are two numbers in the middle of a dataset, their mean is the median. The median is usually used with quantitative data where the values are numerical. But you can sometimes also find the median for an ordinal dataset where the values are ranked category. Okay, find the median with an odd number dataset. We will walk through the step using a small sample dataset with the weekly pay of 5 people. So here with the dataset, we have 5 people here. And then on the step 1, first order the values from low to high. So we have to order the data from the lowest to the highest. After that, calculate the middle position. The middle position, we use the formula n plus 1 and then divide by 2. So we have the values is 5. So 5 plus 1 divided by 2, then we have 3. And then find the value in the middle position. The value in the middle position is the third because we have already found the middle position is 3. And then 1 to 3. So we have the value is $350. Okay, that is the odd number dataset. Let's continue with the even number dataset. In an even number dataset, there is not a single value in the middle of the dataset. So there is not a single value in the middle of dataset. So we have to follow a slightly different procedure. So we have 1, 2, 3, 4, 5, 6. There is no single value in the middle of the dataset, right? And then step 1, order the values from low to high, like before, the same way. So from 130 to 1150. And then calculate the two middle position. The middle positions are found using the formulas n divided by 2 and n divided by 2 plus 1, where n is the number of values in your dataset, like this. And then, so the middle values are the third and the fourth position. Step 3, find the two middle values. Because we already found the two middle positions in 3 and 4, so the answer is 350 and 500. Step 4, find the mean of the two middle value. To find the median, calculate the mean by adding together the middle values and dividing them by 2. So we have to adding together the middle values and dividing them by 2. 350 plus 500 and divided by 2. So the answer is 425. So the median weekly pay for this data set is $425. Next, we continue to the standard deviation. Standard deviation is more commonly used than variance because it has the same unit as the mean and often represents the same central and dispersion tendency of observation as the mean. So this is the formula. I will show you the example on our homework before. Now let's continue to the last part is coefficient of variation. Coefficient of variation is often used to compare the degree of variation in two or more groups of data with different units of measurement or with large difference in the mean. So this is the formula. I hope you guys remember it. This formula and this one. Okay. I will continue to the example, but the example is from our homework on the chapter 2, part 2. Wait. I will move first. Okay. Wait a moment, guys. Okay, this one. chapter 2, part 2. Number 2. For the example, let's jump to our homework, guys. So I will read the question first. The following table shows the blood prolactin concentration before and after surgery in 10 patients with pituitary prolactin microadenoma, trying to explain which indicators are suitable for comparing the variation of data before and after surgery. So we have to explain which indicators are suitable for comparing the variation data before and after surgery. Here we know that the table, we have the preoperative and postoperative, guys. And then we know that we have only 10 items value here. So let's continue into we have to find the mean first. In the preoperative, we have to find the mean. So we have to adding them all up and then divide it by 10. Why 10? Because here we only have 10 items. So we have found the answer is 672.4. And then we need to go into formula. What formula? Before standard deviation. Until we know that the answer is 672.4, we put this into the formulas of standard deviation. We know the answer is 564.65. Okay, this is the step by step. And then we have to find the postoperative. Postoperative is just the same way of preoperative. We have to find the mean and then we input the deviations, standard deviation, sorry guys. And then we found the answer. So what is the next step? Look at in the question. We have to trying to explain the comparing the variation of data before and after surgery. So we have to find the comparing data with the coefficient of variation. Let's jump into this part. This is the formula that we have to always remember the coefficient of variation. First, we have to find the preoperative. The preoperative, we know that the mean is 672.4, and then the standard deviation is 564.65. In the formula that we know.
Excuse me, Lin Yongfu.
Yes, Losa.
I think your screen is stopped.
Huh? Really?
We
Wait.
we just see the coefficient of variation.
Oh. About now? Is it okay?
Okay.
So may I continue or I repeat from the
Continue.
first?
Yes. Continue.
This.
Okay.
Continue. Okay.
Yeah.
So we will continue the coefficient of variation. We know this one is the formula. We already found the mean is 672.4 and the standard deviation is 564.65. In formula, S is divided by X and then multiply by 100%. So we just insert all this data and we found the answer is 83.98. So just the same way for the post-operative. So it can be seen that the standard deviation was used as an indicator. Okay, that's all about the mean, median, standard deviation, and coefficient of variation from our chapter 2, part 2. But the last number, I don't think this is correct or not. I will wait. Oh, I will read the questions first. Provincial Association of Cancer Rehabilitation evaluate the quality of life of 189 members. The scale include 4 dimensions: physical function, physiological function, symptom adverse reaction, and social function. There were 22 items in total. The data are as follows. According to the data, the centralized location index and the discrete degree index are calculated. The results are as follows.
Sorry, excuse me, sorry.
Yes, Lause.
I just we just how about other students? I just see one slide. It's about the coefficient of variation.
Yes,
No, I'm
it
already.
doesn't look no variation. It's still on the coefficient of variation.
Oh, really? Oh, I will start from the first of our homework, guys. Wait. How about now?
It's okay. Yes, it's okay.
Okay. This one is the example of the standard deviation and coefficient of variation. I think I will repeat from the first example. Okay. Firstly, I will read the question. Number 2, the following table shows the blood prolactin concentration before and after surgery in 10 patients with pituitary prolactin microadenoma, trying to explain which indicators are suitable for comparing the variation of data before and after surgery. And then we look at here, this is the table of the blood prolactin concentration before and after surgery. So we have preoperative and postoperative. You guys can see my screen.
Yes.
Okay, I'll continue.
Yes.
So we have 10 items value here. And then we have the preoperative and postoperative. In the questions, we know that we're trying to explain which indicators are suitable for comparing the variation of data before and after surgery. So we first, from the preoperative, we have to find the mean. The mean is just adding them all up and then divided by 10 values here. And we found the answer is 672.4. And then we going to formula of standard deviation. And then we found the answer is 564.65. This one is the standard deviation. And then we continue to the post-operative. Post-operative is just the same way from pre-operative. We have to find the mean first, and then we already found the answer, 127.2. And then going to formula of standard deviation that we have to remember the formula. And then we found the answer is 101.265. After we already found the standard deviation of preoperative and postoperative, we continue to the coefficient of variation. Why we have to? Because in the question we have to comparing the variation of data before and after surgery. And then the formula that we have to remember always, S divided by X and multiplied by 100%. And then we now the mean is 672.4 and standard deviation is 564.65. So in this formula, we know that S is divided by X and then multiplied by 100%. The answer is 83.98%. And just the same way from the preoperative. So it can be seen that the standard deviation was used as an indicator. So that's all the standard deviation and coefficient of variation example. Let's move to our last number. A provincial association of cancer rehabilitation evaluate the quality of life of 199 members. The scale included the 4 dimensions: physical function, psychological function, symptom adverse reaction, and social function. There were 22 items in total. The data are as follows. According to the data, the centralized location index and the discrete degree index are calculated. The results are as follows. The centralized position index mean 135.77 points, and the dispersion index S is 30.60 points. Is the above analysis appropriate? Why is that? So I think this above analysis is not appropriate. Why is that? Because the observed values are not concentrated at the larger end with a negative distribution. So it's not appropriate to use mean and standard deviation. The median and quartile spacing should be calculated. Centralized position index M is 140 points here. So that is the end of the presentation for me. Thank you so much for attention. Any
Yes,
questions?
thank you so much. Your elaboration is very perfect. You elaborate more details about these questions. Very good.
Thank you also.
I will also give you the whole scores for this part. I think you also do more work for this part. It is difficult. Okay, and your answer are all correct. Very good. So how about other students? Do you have any question about this part?
No, sure. I think it's all clear.
Okay. Okay, now I wanted to discuss the chapter 2, the single choice questions. Do other students finish it? Wait a moment. Okay, can you see my screen?
Yes, sure.
Okay, for question
Yes,
one, what's your answer? If there is no fixed value at the large end of medical data, which one is more suitable to describe the central tendency? We have to choose. Which one?
A.
Yeah, yes. We have to choose A, median. Median is suitable for no fixed data, yes. Second, the arithmetic mean is characterized by its comparison with the median. So it means what's the difference? We have to choose.
B.
Yes, very good. We have to choose B, information that make good use of data. And besides, I wanted to focus or say the points. I think every student have to finish each homework by yourself. And in this condition, so you will have a deep memory about this part. And if you have any question, when we discuss it, you can tell me. Because all of the homework are a part of our terminal examination. For question 3, a set of original data has a positively skewed distribution. Positive. So which part have more data? Left or right? Do you know? The left side. Yes, very good. So how about question 3? We have to choose.
D.
The smaller side.
Yes, very good. We have to choose D because more data is in the left. Yes. If the data in the left, so it means they are small. But if they are in the right, that means they are larger than the left side. Question 4. What's the answer of this question?
E.
Yes, the last one. We provide data and describe the distribution characteristics of data. So we know it's a normal distribution or a screwed distribution. It's very important part of our descriptive statistics because we will learn more about the t-test or chi-square test. When we choose t-test or chi-square test in the research, first we have to know whether it is a normal distribution or not. So question 5, coefficient variation is mainly used for which answer is correct?
A.
Yes, very good. And I think Ni Yongfu also elaborate in details. Very good. 6. For the data with approximate normal distribution, the index to describe the degree of variation should be selected as follows. So which one?
E.
Deviation.
E.
Yes, standard deviation. 7. What's your answer?
E.
E.
Yes, quartile. The interquartile is suitable for this part because it is a screwed distribution. So we can't use standard deviation. Standard deviation is suitable for normal distribution. Okay, 8.
B.
B.
Yes, we just learned the central trend, central tendency, and the discrete tendency in chapter 2. Okay, 9. We have to choose A, okay? I forgot to delete the answer. But please pay attention to which of the following statements is true about the mean and the standard deviation. So the mean could be negative. The standard deviation impossible is true. Why? Why here? The standard deviation may be negative is wrong. Because by the formula, we use a square, yes?
Yes.
So we have to choose A. This is the right answer. Okay, how about this part? Last day, maybe yesterday or more previous time, some students ask me, he or she think when we calculate it by the formula, it's a little difficult or it's easy to calculate or have some mistake. Yes. So I just want to say a little about it. Because when we finish our theory, I also want to tell you the method how to calculate some data on our computer. Use Excel or SPSS. this is the tool for our medical statistics. So today I just tell you a little about median, average, sum. Do you have an Excel? Just like this part, do you have an Excel?
Yes, I'm sorry.
Okay.
Yes,
So this is the example of from Lin Yongfu's PowerPoint. So if we want to know how many data in this part, we can use count. Sorry. So we know here is 8. Yes. This is also calculated by some formula, but this was set by Excel. And if we want to calculate the median, we also can use the formula. We use an equal and use median. Then we choose the number we want. Also confirm. Oh, no, this is not the right answer. Wait a moment. I'm sorry. I think this may have some formula. I want to. Do you have a SPSS in your computer?
No, sorry.
Oh, okay. This calculates the median, and also can calculate the sum. Yes, sum. This is some information for our Excel. We can calculate a small group of data by Excel. But if we have a large group of data, if we have more patients in our research, we have to use SPSS. So after all the theory class, I will introduce some information about the SPSS. So I hope you also can prepare the stool. But if you don't have, it also doesn't matter. It doesn't matter. You just know how to calculate, or you just need to know the stool. If one day you need to use it in future, I think you will learn it by books or internet. That's okay. Okay. Do you have any question about today's class?
No, sure.
No.
Okay. Okay, please turn on your camera. I want to take a photo of all of us. Okay. 李艺彤, can you help me? Please turn on your camera. Open your camera. Oh, I know why, because I share my screen. Okay, I can take. Okay, how about other students? Please open your camera. Will is 王美花张福明、彭威年、王秀梅。How many students in our class? When we can't choose. Okay, open your camera and smile. Okay. Okay, Pen Wei is a gentleman, handsome. Okay, thank you so much. I want to finish. We can have dinner in different area. Wish you a good night. Bye.
Thank you, Rosha.
Thank you, Rosha.
Okay,
Good night.
bye.
Take care, Lola.
You, Rosha.
谢谢老师。
谢谢。